Hello everyone. Okay, let me present my project to you. The goal of this project is to design and implement a binary counter that counts from 0 to 7 or 7 to 0 based on a switch input X and display the current counter on a 7 segment display. The project was coded in a VHL and deployed it on a FPGA board. Okay, so now let's tackle how does it work. I designed a system with three key components, which has a clock divider, a counter logic, a 7 segment display. Now let me walk with you through the input and the output. So in my input I have a clock which is 50 megahertz clock input, and then I have a reset button which when you reset it goes to 0. Now I have the X switch which calculates the direction. Then we also have the light binary. Now let's move on to the clock divider. The clock divider provides a 50 megahertz clock, which is too fast to observe with visual eyes as a human being. So I created a clock divider to reduce this to around 1 hertz. Use a 26-bit counter clock divider. When the clock divider reaches 25 million, which is equivalent to 0.5 seconds, it will toggle a new signal, slow clock, and reset. This slow clock drives an actual counter. Okay, now let's move on to the counter logic. I used a 3-bit register counter to hold values from 00, 00 which is 0 to 111 which is 7. The counter will update. If a reset is pressed, it will be equal to 0. If X is equal to 0, the counter counts up, looping from 7 to 0. And then if X is 1, the counter also will count down, looping from 0 to 7. Now I also have the 7 segment display decoder. I wrote a decoder that maps each binary counter 0 to 7 to a 7 segment display pattern, as you can see. Okay, and then I also debug the light to make the debugging easier. I connected the counter directly to a LED 2 is to 0. This way I could monitor the binary counter on the LED which were watching the 7 display. Okay, now let me show you maybe some just quick process that you can see. Okay, so after doing this, having the code, I then move on to compile it. After compiling it, I move on to assignments to the pin planner. Then pin planner, after pinning the plan, you can see them here. So I have the outputs and the inputs of my pins, and then again I'll move on to compile it again. Then after compiling it, then I move on to the tools. Now I wanted to connect my program to the board. Okay, the FPGA board. Then I move on to the programmer, press programmer, and then you will then start here, compile it until it reaches 100% saying successful. Then your program will be successful. As you can observe on here, now it reaches 100 successful. Wow, that's really good. Okay, it shows that the hardware description languages can be used to build a reliable and responsible digital system. Thank you guys for listening.